In this video, we're going to look at relations and functions. So our first vocabulary words are continuous and discrete. So there's two types of graphs. Continuous is the most common. It's where we look at a smooth curve, a line. A discrete graph is going to be just a graph of points, and they are not connected. The reason for that is that in this situation, not all values are going to be needed or make sense. And we'll talk about that in a second. So here we're looking at graphs to situations. We're looking at air temperature. It's increasing, so that means the graph should be going up. It's going to remain constant, which means it should be level. And at the end of the day, it's going to increase slightly before dropping sharply. So you see we have four words that describe the motion of this graph. So we should see a graph with four distinct parts to it. So here, if we look at graph C, we see that we have a temperature that increases, it remains constant, it increases slightly before dropping then sharply. This is an example of continuous because it has a connected line. The reason it has a connected line is because time is continuous. Time never stops. It doesn't jump from one time to another. Time is just moving. Also, temperature is continuous. Air temperature can't automatically jump from one value to the next. It's got to hit all those values in between. So here's an example of a discrete graph. It's just a graph of dots. Here they're just collecting attendance per year. They're not looking in the middle of 1 year. So like if this is year 1 and year 2, they don't care about any points that would lie between because they're only looking at each distinct year. Also, people are counted in whole numbers only. So we're not going to look at values that are in between here that may be decimals. So here we're going to sketch a graph. So first we need to decide if this is continuous or discrete. So in this case, we're going to say this is continuous because time is continuous. Time doesn't jump from 1 minute to the next. Also, speed is continuous. Your car can't go from 0 to 60 just like that. It needs to accelerate. So this is a continuous graph. We need to enter the street, assuming we didn't, speed around the corner. We have to speed up to go onto a street. We have to then drive at a constant speed. Then we're going to stop. In order to stop, we must slow down. When we stop, speed is 0. And then we're going to continue from there. So key ideas, again, discrete has many dots that are unconnected. Continuous, we're going to have a line. So now if we look at more vocabulary, a relation is a set of ordered pairs. A set can be 1, can be 2, can be 3, it's a group. It could be infinite. It's ordered pairs. A domain is the set of all of our x values. The range is the set of our y values. And a function is a special type of relationship in which every domain has exactly one range. Not more than one, just one. So here we're given a set of ordered pairs. There are 3 ordered pairs in our set, and we need to write this in 3 different ways. So we can write these ordered pairs as a table. We have our first x, y coordinate, 2, 3. Our second is 4, 7, 6, 8. If we were to graph these, we just need to make sure that our x values correspond. So here we can just use each line as 1. And we can do the same on the y. So we have 2, 3, 4, 7, and 6, 8. Just make sure that you're paying attention. Every dot should have, like this guy has an x coordinate of 4 and a y coordinate of 7. Thus, 4, 7. Okay? And then finally, we can do a mapping diagram. A mapping diagram is very similar to a table. It's just going to map it. It's going to show where it comes from. So if I use my inputs on the left, outputs on the right, the input 2 maps to 3. The input 4 maps to 7, and the input 6 maps to 8. The question says, give the domain and range. Domain is the set of all of the x values. Here I only have 3 x values. 2, 4, 6. My range is the set of my y values. I have 3 y values, 3, 7, next part of it says tell whether it is a function. So in order to tell if this is a function, we need to make sure that every input has exactly one output. So we can look here. The mapping diagram is probably the easiest way to see this. 2 maps to one other value. 4 maps to one other value. 6 maps to one other value. So yes, this is a function. If we were to have, let's say, another ordered pair, like 6, 10, now this is not a function because this input has 2 separate outputs, and that's not allowed. If we were to write that on our mapping diagram, 6 would have 2 different outcomes, and that would not be a function. If we want to look at a graph to determine whether or not something is a function, we need to use something called the vertical line test. The vertical line test says if we draw a vertical line, it should only cross each point once. So if I were to move this along my relation here, it crosses once, once, once. That means it's a function. If I were to have another ordered pair, let's say down here, now this is not a function because even though it crosses those guys once, it crosses those twice. That would mean it is not a function. But as it's written, it is a function. And so here we just have it written down. A vertical line test is used to determine if a relation is a function. If the vertical line hits only one point, then it is a function. If it hits more than one point, then it is not a function. So our last example, we're going to find the domain and range of this graph. Now this is different because this is a line, this is continuous, which means there's an infinite amount of points on here, and we need to write them all out. We can't possibly write out an infinite number of answers, so we use inequalities or intervals. So domain is the set of all of my x values. So if I were to look at all of these x values, they run left and right. That means I need to list all the values from left to right that this function touches. One way to do that is to maybe use a screen shape. Okay? If I were to look at this, I first see my line when I get to an x value of -3. My line stops when I get to the x value of 1. It stops right there, it does not go past. So all of my x values are between, all of my points are between -3 and 1. I could use an interval to represent this as well. Those say the same thing. If I wanted to look at my range, I could use my screen shape in a different way because range talks about up and down because it's y values. So if I'm now looking at all of these y values, I first get to points when I hit a y value of -4. My points continue until I hit a y value of 0. So they're all between -4 and 0. And if I used interval notation, I would say -4